So today we will do MPLS VPN practical.
Hello.
Hello.
Yes, sir. Hi, this is Milind here. So, earlier we discussed about that some dumps need to be procured, right? Lap 7, which came, and there was some 3,000 rupees was the right fee. So, I mean, I haven't got any WhatsApp group or any WhatsApp message. So,
I will check with that. Okay, tomorrow I will tell you.
okay, sir. Yeah.
This R3 and R5 will be your provider edge, and this R4 will be your P router. So, provider edge 1, provider edge 2. P router, and here between R3 and R4, R5, sorry, we're going to run Empty Bgp, and here in MPLS Cloud we're going to run OSPF also with LDP, and this is your customer 1, customer H2, customer A1, customer P1, customer H82, customer HB2. Here I will create VRF A, VRF B, here also VRF A, Here on this is PE2. Here this is called PE2C routing. Okay. Here PE2PE routing where I am running MPPG. But provider edge to customer, it is up to the customer what he wants to run. Suppose here I will use static. Here I will use reprop. And here I will use OSPF. Here I will use EIGR. Fine. And then customer routes will be here I create a loopback 1.1.1.1. Here also I'm going to create a loopback 2.2.2.2. Here loopback 3.3.3. Loopback 5.5.5. Now API will give 10.1.1.1. Here it is 10.1.1.2. 11.1.1.1. 11.1.1.2. 12.1.1.1. 12.1.1.2. 13.1.1.1. 13.1.1. 14.1.1.1. 14.1.1.2. 15.1.1.1. 15.1.1.1. Okay, so this is HLSR1. This will be HLSR2. This is core LSR. So CLSR. Okay. Set. Now for Mppgp, we will going to I was just going to form their neighborship with loopback. So loopback I will create on HLSR1 4.4.4.4. Here I will going to create loopback 6.6.6.6. So I will create on the edge LSR. While loop back, I will going to give neighborship. That will be very indirect neighborship. Because in VR, here it is not required. Maybe topology is like this. Then in BGP, we use loop back addresses because of redundancy. So if you will give interface in this kind of scenario, if this is failed, you cannot talk. But if you will give loop back, if this fails, you can go from this. Fine. Okay. So we will start with the link. Alright. A1. Okay. So interface 0/0. On the customer edge, we are not running any VRF, nothing MPLS. Okay. And we have a loop back interface, loop back 0. What I will do accordingly, let me give the default. I have configured the first customer. Now R2 I will configure. Here I have to run RIP. On the customer edge, it's a simple configuration of RIP, but when I will do on the provider edge, we have to do with VRF. With VRF, we have learned how to give static route or default route, but so far I have not taught you how to give OSPF, ERGRP, and all the other protocols. So once you will have to try that. Even BGP I will show you. So, interface F0/0 shut. Interface and Dr. RIP version 2 not summary network 11.1.0 2.3. This is hardware configuration. Now jump to R6. Here I'm running OSPF. Now you need to understand one thing. Here also I'm running OSPF at MPLS end. Okay. Towards the customer end, I am also running OSPF. So what I need to do, I need to separate their database. Meaning, I will give OSPF process ID. I will change. Here I will give 1. Here I will change it to 2, or I'll make it 10. Suppose. What will happen? This process ID means your databases are separate now. This information would not jump into this particular OSPF. Okay, so we need to, if you're running same protocol on the provider edge and toward the customer edge also, just you need to change the process ID so that their databases should be separate. So right now R6, nothing you have to do much on R6 means like right on customer edge. Those things will come in your provider edge. Router, OSPF, and 10. Sorry, I have not configured anything for his putting a prompt that he cannot pick any router ID because I have not configured any IP address. So interface F0/0. No sure. IP address 14.1.1.2. Come out of this. Interface loopback. IP address. Now network 14.1.1.0. Area I'll make it 100. Okay, and one loopback is also there. So 2.2.0. Now on R7. Face F0/0. Dot chat. Dot face loopback 0. IP address. Router ESGRP 100. Node summary. Network 15.1.1.0 and 5.5. The customer edge side is configured. Now I'll enable first of all this P router, which is easy configuration. Nothing, just need to give IP, enable OSPF and MPLS. Configure terminal interface F0/0. Type no shut. IP address 12.1.1.2 interface F0/1 IP address 13.1.1.1. And what you need to do, router OSPF as OSPF1. Okay, so network 0.0.0.0 to 55 area 0. I will say all the interfaces I will called inside OSPF and enable MPLS LDP autocomp. Okay. Now understand only this interface, okay, and this loopback. Now why? Because why this loopback? Because this loopback I need to see form empty Bgp. When you want to form the Bgp neighborship, first thing reachability should be there. So reachability we have to give via IGP only. So via OSPF I will give reachability to this loopback. Then we will form Mppgp neighborship. Little bit different command. So Mppgp means it is going to support VPN for route. We'll talk about that. But right now understand this and this interface, this and this I have to advertise under OSPF, and then I have to apply MPLS LDP autoconfig code. So only this is your MPLS cloud. So on Edge LSR1, figure terminal. Let me give the IP addressing, but that side I won't give because I have to enable BRF. So first I will configure F1/0. No CTP enable. No shut. IP address 12.1.1.1. Okay. And interface loopback 0. IP address 4.4.4.4. Now you have to make sure you will not give under router OSPF all 000, meaning all interfaces you have applied OSPF to. But here only the egress interface towards the service provider and the loopback is under OSPF. So you have to give a specific route 12.1.1.0 area 0 and your loopback 4.4.4.0. Fine. And MPLS will be applied on these two interfaces. So MPLS LDP. Okay. Yeah.
Sir, we will not configure the BRF here.
We will step by step.
Okay.
Then on R6, which is Edge LSR 2. Interface F0/0 and no shut IP address 13.1.1.2. Okay. And interface loopback 0 IP address 6.6.6.6. Here. Okay. Now router OSPF1 network 13.1.1.0 0.0.55. Sorry, area 0 and loopback also 6.6.6.0. Okay, and you need to give MPLS LDP auto confirm, meaning only on the loopback and on address 0, MPLS is enabled. Okay, so I'm just waiting them for LDP neighborship. So, shut up. So on R6, that is R, I tell this R2, okay, LDP neighborship is fine. Now, main configuration is your will create VRF. Okay. Now understand, I have told you there could be a possibility this subnet is also same, this subnet is also same. So once, because here I'm not enabling VRF, this is global. Okay, so this is your global routing table here, and here is your VRF enable. Okay, so once it is like a trunk link, when similar routes will go, how you will going to differentiate with the help of RD. I have told you it's a 64-bit number, and it should be locally significant, means it should be unique at your end. So for VRFA, I'm mentioning here, RD, I will take suppose 100:1. Okay, and for VRFB, I will take RD 100:2, so that if suppose you have similar routes also 10.1.1.1, I will put this tag and 10.1.1.1 100:2, means so that other side can differentiate. Okay, fine, they both are different. Okay, so tag this is about RD. Now I have told you one more tag will be there, which is route target. Okay, so RD. What RD will do? RD will segregate that these two are different routes. Okay, these two are different. Now, how would they know that? See, second thing is, now when BGP is sharing the update, okay, how would they know that I need to send this particular route to VRFA and this route to VRFB? Where their RT will come, route target. Understand, this RT is an attribute of VRF. Now, RT which I am going to write is an attribute of BGP. It's called extended community. Okay. So what I will going to do, RT, one is RT export, mean when I will export the route, it will put the tag of 100:, let's say 1. RD is different, RT is different. Okay, so it could be different also tag, but I'm just saying RD and RT are not like dependable. If you are giving 100:1, you cannot give an RT 100:1, because RT meaning is separate. RT is related to BGP, RD related to VRF. Okay, so both are different. Okay, means export meaning if I will send this route, there is one more. This is RD, and this is your RT 100:1 again. This is your RT. Once it will reach here, now this is global routing. Now you need to understand how this guy will differentiate that, either like you have to go to VRFA or VRFB. So what he will do here, what I will do, let me clear this. One more thing, Here I will write first of all with respect to that RT 100 colon 1 on the R1. R6 will say if RT with import. Import means if it will come with 100 colon 1, okay, take it, import it. Okay, I am exporting with 100 colon 1. He is saying if any tag will come with 100 colon 1, give it to VRFA. Okay, and then what he will do, he will also, when R6 will send routes, RT, it will put export 100 colon 3. Meaning when I will send route to you, I will put a tag of 100 colon 3. And once it will reach to HLSR1, how HLSR will differentiate to which VRF I have to give, because here I will mention RT import is 100 colon 3. This is clear? Import export. Only this is a little bit you need to understand. RD is easy. RD can give anything. Okay, it just need to differentiate the route. Okay, and either it's up to you. You can give RD same on the other also other device. So here.
So can you please explain again? It's quite confusing.
Now, first of all, this is RD, which is separate with RT. Now suppose 100 colon 1, that is your RT, and your route is 10.1.1.1, or I'll say you're sending the subnet. Now here also you're doing same thing from R2. Suppose it's the same subnet. First of all, who will differentiate between these two same subnet? RD. Okay, here I will say it is 100 colon 1, this is 100 colon 2. Your route is differentiated. Okay, they can now say, okay, this is different, this is different. Now that is VRF attribute. Now once it will reach to R4, how would they know to which VRF they have to go? VRF A or VRF B? Okay, here comes RT then. So that's why we use Mpgp also, because it's a part of Mpgp route target. Now when I have sent route from R1, okay, once it will reach here only they will put a tag of RD and RT, and RT I will put 100 colon 1. Okay, this is for segregation to which VRF you belong to. Okay, 100 colon 1. Now only export thing will come right now. Import I'm not talking about. Once your route will reach here, this route will reach fine. He is saying he's also sending route, he's also sending route. First, how you will going to differentiate these two similar route? With the help of RD. Okay, fine. Next thing, what you need to check, BGP will check in the update packet. What is the RT? RT is 100 colon 1. Okay. Now it will check in this VRFA what is the import command. Now RT is saying import 100 colon 1. Okay, means it is match. So what he will do, he will import to this particular customer. Okay. Similar way, what I have told you, when this guy will R6 will send a route, suppose he is sending 14.1.1.0, RD is what? RD is 100 colon 3. Fine. What is RT? RT is export RT, 100 colon 3. Now when this 100 colon 3 will reach here, it will check who is telling that import 100 colon 3. Okay, this guy is saying import 100 colon 3. So route will go towards this. Clear?
Yeah, sir. Thanks.
This is the only small part, but yes, important part. RD, RT. This comes under control packets. Control packet meaning when BGP, I will mention Empty Bgp, will share updates. Okay, like OSPI, when they share update, they fill their routing table. Again, they are filling their routing table with these are control packet. Here you require RDRT. Okay, once my topology is ready, then I will tell you with this RDRT, they are sending one VPN label also. That comes for data packet. Because when you do ping, RDRT won't go. RDRT will only come when you are sending a router, okay, via Mppgp. Otherwise, it won't go. Okay, that concept will come only with Mppgp because this will become VPN v4 route. How? Because your 10.1.1.132 bit and your RD, which is 64 bit, make it 696 bit route, which is called VPN v4 route. Okay, RT tag is separate. The VPN v4 route is called your IP plus RD. This is called VPN v4 route. Your RT is for the segregation to which VRF you belong, and this command is required. If suppose you have not given import command, it will drop the packet, okay, and it will call that ARF, automatic route filter. Okay, if you want to give import command here, it will drop the packet here. Okay, and that is called automatic route filter terminology. VPN label we'll talk about, but understand more about RDRT right now. Okay, now I will going to configure. So let me go to HLSR1. Now understand again. First of all, create VRF. You know how to create. Okay, that part you are aware with. IP VRF A. Now put a question mark. You have RD, RT, import, export. All commands are there. Okay. So what I will do, route distinguisher, I will say 100:1. Okay, and then route target export. When you are sending, put a route target of 100:1, and if any route is coming from the other side, route target import. Okay, if that tag in RT is 100:3, okay, take it. That is meant for you only. Okay, this is for your IP VRF A. So to show history, so understand this is for IP VRF A. Route distinguisher 100:1. Okay, if route will go 10.1.1.0, okay, it will add 100:1. This complete will call VPN v4 route. Okay, with this RT of export 100:1 will go. Okay, plus one VPN label is also. Well, these routes are going back and forth when they are exchanging the routes. Now it's time for VRF B. So IP VRF B. Okay. Now here if I will say RD 100:1, see 100:1 already in use by VRFA. So locally significant. It should be unique at your end. Otherwise, if tag is also same, then you cannot differentiate, right? Because 10 is going from here, 10 is going from here, then 100:1, 100:1, again similar. So then RD does not make any sense. Okay, so it should be different at your end. Clear? Now you have like one command, which suppose command is route target both. Both mean your import and export have same tag, meaning when this guy is sending RT export, is exporting with 100:1, 2. Okay, same thing, RT import. He's importing also 100:2 because it's see here I can give possibilities there that here tag could be same. Fine. So accordingly I have done. So here I will say suppose RD. Now here in the above scenario VRFA I change the RD on both sides. Now other possibility is RD could be same also 100:2 because it should be unique at your end, not on the different router. It could be same. Now RT export 100:2 RT import 100:2. Fine. So 100:2. Fine. So this configuration is done. Now same thing I will do it. I will just configure HLSR2 also. IP VRF A. Okay. So accordingly, whatever RD RTP have taken, I'm going to assign that only. RD 100:3 RT route target export 100:1 and I'm sorry route target export 100:3 route target import 100:1. Okay. So IP VRF B RD is 100:2 route target will I'll write both 100:2. Fine. So this is I have configured a route target and route distinguisher. Okay. Now what I will do, these interfaces I will assign under VRF. So this interface is F0/0 and F0/1. So now interface F0/0 no shut IP VRF forwarding A. Okay, and IP address I will give 10.1.1.2 55.55.0 and interface F0/1 no shut IP VRF forwarding B. So IP address 11.1.1.2 and HLSR2 will do the same thing. Interface F0/1 no shut IP address. Sorry, first I will assign IP VRF forwarding A and IP address 14.1.1.1 and interface F1/0 no shut no enable okay. IP address IP VRF forwarding B IP address 15.1.1.1 so basic configuration is done. Now what we will going to do, P2C route. Okay. So let me configure now on on your edge LSR1 towards your customer 1 R1 that router is. I will configure static route for that. That route is IP route for that customer, IP route VRF. This you have learned that how to give static route 1.1.0. Next stop is 10.1.1.1. Fine. Now you need to give RIP towards VRFB. Okay, it means towards your R2 route. So how to configure router? Now this is under VRF router RIP. Okay, address family IPv4 VRF B. Okay, now under this call version 2, no auto summary, and your network, which is 11.1.1.0, and okay, so show IP route VRF B. I just need to check whether they are exchanging route or not. If not, I need to solve that. So that loopback information should come. Okay, so it came. Fine. This is how to enable RIP and VR. Now we'll jump to LSR 2. Here, first of all, I will configure your OSP. So command is little different. Router OSPF and type the process ID and VRF A. Enter. Clear? Now just give network 10. It is 14, right? 14.1.1.0 0.0.0.255. This side I have put area 100. Okay. Now the VRFB toward R7 and router. It is a little different command. Okay. First of all, router I will say EIGRP1. Now this one which I have given, this is a dummy autonomous system. Meaning, when I will type this command address family IPv4 VRFB, now I will type the real one. Now they made this command in such a way, suppose if here also if here also you are running EIGRP, here also you are running EIGRP, here autonomous system is 100, here autonomous system is 200. So what you have to do, this is router EIGRP1, dummy AS. Now go inside this address family IPv4 VRFB. Okay, now type the real AS, because accordingly R7 I have configured 100. Okay, otherwise you should know that different autonomous systems they can't talk, so you need a redistribution for that. So, but I have to type one command is there, autonomous system 100. Now inside this type network 15.1.1.0 and no auto summary also. So they form neighbors. So what I am saying, if both sides you are running EIGRP, so here you can change again autonomous system. You need to go back and again give one more autonomous system. Sorry. Then you have to give this command. Right now it is under VRFB. Suppose that particular interface is under VRFA. Go enter, okay, and type autonomous system 200 and give it route. So in EIGRP it is little different. Okay, because first you create a dummy AS. Okay, inside that you have to give the real AS. So to show history, this is what we did. We have configured OSPF in this way. Okay, all different commands. EIGRP this. Okay, Static route, you know, simple. Sorry. One second. Do show static route is easy. Just we have to put VRFA and rep address family IP for VRFB. That's all. Okay. So we'll just check on HLSR2 show IP route VRF A. Okay. Show IP VRF Right now P to C routing is going fine. Now we're going to enable empty BGP. So you need to enable between this and this. Router BGP 100. Okay. First of all, you need to understand here I will going to run purely VPN v4 route. So I need to disable IPv4 because it will generate uh, like probes for VPN v4 route also. So why to waste your bandwidth? So first command you should give no to BGP default IPv4 unicast. Disable this. If you are not running normal BGP with IPv4, I'm going to run with VPN v4. Okay. So then give neighbor command. Neighbor, who's your neighbor? Loopback 6.6.6.6. It's remote AS. I will going to give 100 only. Okay. Then as it is a loopback address, so you need to give update source loopback 0. So 6.6.6.6 update source loopback 0. Okay. Now you need to enable VPN v4 address family VPN v4. Okay. Neighbor. Now you have to activate this for VPN v4. And now if you have studied, community is an attribute, a tag will be there which is not carried. So you need to give this command in BGP when you will learn that community attribute also, that 6.6.6 send the community, because whatever tag I'm sending, it won't carry to the next router if you won't put this command send the community in. If you have learned in BGP community attribute, that is called standard one. This is called extended. Okay, this will carry your RT. Now come out of this. Now what we're going to do, you configure the other side of your HLSR router BGP 100 neighbor 4.4.4.4 with the remote AS 100 and neighbor 4.4.4.4 update source loopback 0. BGP default IPv4 unicast, and then neighbor whatever commands are. Then we'll enable address family VPN v4 neighbor 4.4.4.4 activate, and neighbor 4.4.4.4 send community extended. Okay, there are. So neighbor is up. Okay, I will do that now. Enable the capture. Show RDRT. Now understand one important thing. You need to, when these are the customer route, it should reach here, right? So now how it will? You need to do redistribution because here you are running static. You need to redistribute the route from your customer to the Empty Bgp and from Empty Bgp to the static. Static does not here does not require because IVF default route there. But when it comes to the PIGRP OSPF, we need redistribution. Otherwise, it won't work. But before that, one thing I wanted to show you on your HLSR1 show IP route. If you will notice, this is /32. Okay, but in on HLSR2 show IP route, you have installed with /24, right? 6 route. But when it is going to the other HLSR, it is /32. Why? Because in OSPF, when you advertise loopback, it will take /32. If you want that it will work normally, whatever subnet you have assigned, it will go accordingly. So for that, you need to do, because here issue will come, because you exchange. It will show you one thing. Show IP MPLS LDP binding. See, I have learned 666 with /32. If I want to go to 666, okay, I will put this tag. But understand R7 when it will reach here, show IP route. Not R7. Show MPLS LDP binding. Here he assigned tag with respect to /24. So issue will come. Okay. In MPLS, there is issue with summarization also, because maybe at your end it's /26 or /24, but when you do summarization, other side it will be some different. Okay. So issues are there. So here to solve this issue, first of all, in OSPF, because I have advertising loopback, and loopback always takes /32 in OSPF. So go to interface loopback 0, IP OSPF network type you have to change point to point. Okay, same thing you have to go to HLSR2 and interface loopback 0, IP OSPF network point to point. So once you will do point to point, otherwise network type, I think loopback. The network type called loopback also, where it will take /32. Let me confirm that. Okay, so HLSR. Now, if you will check show binding, it is taking /32, but Let me show IP route. Now routes are coming with /24, installed with /24, and show IP route. So /24/24. Otherwise, if you are trying to reach the other customer, it won't work. Okay. So this is first issue you need to check. Secondly, now we need to do redistribution. Okay. On HLSR1, now what you have to do under router BGP 100. Okay, now BGP is common for both VRF because I have applied on the global side. Now address family, first of all, VPN V4 VRF A. Okay, I will do redistribute static. The static route which I have given, it should go towards the other end. So when it will redistribute, it will put RD and RT. Okay, and then address family VRF B. Okay, okay, B redistribute RIP. Fine. Similar thing you need to do, come out of this. Go to router RIP because I want that other guy should also send routes to me, my branch office or main office, whatever. So router RIP address family IPv4 VRF B redistribute BGP 100 with a metric of 1. Okay. Now this side is done. Now we'll jump to the other side of HLSR2. Here, same thing, router BGP 100. Address family IPv4 VRF A. Okay. Here you do redistribute OSPF 10 VRF A. Now here by by default it can redistribute internal route, but I'm just telling it won't redistribute the external route. If it comes like external routes you want to redistribute, at that time what you have to do, you need to type this command internal. Options are the external 1, external 2. By default OSPF comes for redistribution, it can redistribute the internal route. I'm just telling you, if it's external, it won't redistribute by default. So you need to type this command, redistribute external 1, external 2, E1, E2 route. One is this. Now come out of this VRF B. It's time to redistribute EIGRP. So redistribute EIGRP 100. Fine. Come out of this. Now go to OSPF. Router OSPF 10 VRF A. Here to redistribute BGP 100. Okay, subnets. Okay, exit router. Now go to EIGRP 100. Okay, address family IPv4 VRF B. Sorry. BGRP 1 address family IPv4 BRFP anonymous system 100 redistribute BGP 100 with the metric the IRP has bandwidth delay and all those things. But let me check on R6. So I figured it out. Okay. Customer route fine on R1. So I figured out. That I will check the issue. But before that, let me open the Wireshark. I want to show you that RDRT. BGP updates. You will see Empty Bgp is sending VPN label and RD. This is label stack 19 fine. And VPN label is also there. Here is RT route distinguisher label 19 fine. Extended community. This is your route target. Okay. So yeah, within a BGP update. Now, why Mppgp? Understand one more thing. I have explained it before only. No other protocol right now support this VPN v4 route. Only BGP. That's why most we are using Mppgp. Secondly, now Mppgp are important because it is going to carry your RD, RT, and VPN label. Okay. Now VPN label is similar concept of RDRT. So the difference is, suppose you have created VPN label here 40. Here is side, that side they have created 100. Now what happen when you do ping? What it will do? I'll show you. Let me confirm one thing on R2. Sure, it out. They are learning about the route. Now on Edge LSR1, if I will show you, show MPLS VPN bind. Okay. In binding right now, the local level, I want to reach to right. Understand how it works. Now once you want to reach to 222, right, on the other customer, it will hit here. This belongs to VRF A, right? It belongs to VRF A, meaning on edge LS server 1, first of all, show IP route VRF A. Okay, VRF A is saying, I have learned about 2 via BGP. Who's next stop? Now understand, they won't change the next stop. See, once BGP has given a route to you from here, it won't change the next stop. Okay. So that's why it's pointing that the next stop is 6.6.6.6. Okay. Second lookup. Second lookup now, who is 6.6.6.6? I don't know about 6. Then check in, show IP, global routing table. I'm just telling you the sequence. 6 is saying reachable via 12.1.1. Actually, this has not happened, but I'm just telling you for your understanding. It will check the fifth table. So 12.1.1. So show MPLS LD, sorry, forwarding table. Okay. I want to go to 6. Okay, put this level. Understand. Next stop is 12.1.1.2. But actually, which command they will check? I have told you. Check the SEF command. Show IP SEF. Okay. Which VRF it is? VRF A. Detail. Now it will tell you put these two tags. Impose two tags. One tag is MPLS tag. Other is MPLS VPN tag. Okay. How to check? Now once let me enable one packet. I have stopped this, right? Let me enable again. Let me stop this. This you need to understand. Ping to 2.2.2.2 source 1.1.1.1. Pinging, right? So MPLS is working fine, but I need to show you that VPN there. Now this is data packet. If you will see here, you have, let me first of all stop that. Otherwise it will hang. Okay, if you will notice, you have two tags. So it's coincident that both have same label, 19 and 90. Okay, one tag is for swapping, other tag is for identification that once it will reach to the other end, to which VRF I will assign, VRF A or VRF B. Okay, when you do redistribution, when you generate that Empty Bgp route, in the update only, it will send a VPN label, which is common. Okay, like RDRT. RDRT for control message, this VPN label is for your data packet. Now we'll check here. Show MPLS forwarding table. Right now, you want to go towards 6. Okay, because he's saying next stop is 6. So put 19. And if you will notice, where is that? 1 second. Which I have seen the wrong one, I think. This is source is 1, destination is 2. But here it is saying 19 and 20. One second. LSR. Show IP Bgp VPN. So 19 for 2. These are called VRF tag. But when one will come, okay. When one will go into a destination, he will put 19. 18, okay. He will impose 18, 19. But I need to check one thing. Once it will reach here, so now it will be popped. Okay, so the one label will be popped, which is 19. They will check from the reply thing. HLSR to show IP set URL A tags. Saying here you need to put 18 and 19. So reply, here it is fine, 18 and 19. So once it will reach here, you will see reply, 19 will be left. So it is not this packet, 1 second. 18, 19, I will start from here, reply packet, that is correct, that 18 and 19 should be imposed. Once it will reach here, it will be only 90, meaning this 18 was MPLS tag. This 19 is VPN tag, meaning now it will tell you at the destination to which VRF you have to give that particular that ping packet, so that reply can come properly. Okay, to understand two things. Which is important. But let me check. Other side is not giving me the right information, but this side is giving me the right information. But right now, for your understanding, two concepts are very important. Apart from that, everything you have learned in CCNP, distribution and all. Okay, that is not new for you. One Empty Bgp, if you have learned the community, just extended community, you need to, like, you should know VPN v4 route. I have told you, when any IP route will combine with RD, it will become VPN v4 route. Okay, RD is there because when BGP will send the control message, it will segregate to which we are. So with the help of this export import command, okay, this all RD concept will come in your control packet. When you are sending ping data packet, during update only, see, from this update only, they are sending one label, VPN label. Suppose I am saying for me you are 18, he's saying when you want to reach me 19. Okay, so now he gave me his 19, I gave my 18 to him. So when he will put one 19, and then he will put one, suppose whatever is the MPLS label 70. So first label, this label is for your MPLS VPN, means when this data packet will come, to which VRF I will assign. Because when these routes are exchanged, different VPN labels are generated. Okay, and this 17 is only for MPLS for swapping purpose, because label switching will happen. It is not meant for label switching. Other tag. Okay, one tag meant for label switching, other is for route segregation. First of all, you have to understand this much. Then do this practical again. Okay, and use all these commands, because all possible commands I will show you. See, show IP, BGP, summary, Won't show you anything. Yeah, show IP BGP VPN v4 all. It will show you what routes you have learned. Okay, but if you are like you want to see the tag also, then put a tag command. VPN show IP BGP VPN v4 all. Before was 1 second. The command is show IP BGP VPN v4 VRFA. Okay, so what route they have given to VRFA and what route after redistribution it has given, it has learned from VRFB, that information will be there. Okay, and if you want to the label information, best command is show IP step. Okay, and show VRFA detail. So now it will tell you that these two labels. Okay, now it is showing 1919 level. Okay, it has to go. Now it's fine. Look about the issue before. So 1919 label. Okay. Then I did some mistake. F1/0. Okay, I have said detail. Okay, then it will go toward F/0 when next object this. Then put this label. Fine. Go to the down. 1 second. Then we go to reach to. I will give this note to tell you. 1 second. We are at 5. I will check this. I have never noticed before. I will check what is the meaning actually. Fine. Secondly, now if you want to verify also on R1, because if you remember, trace route will give all the information. Okay, so I am not using that command called to filter TTL command that propagate TTL. So source 1.1.1.1. If you will see, so it is using 1919, right? These two labels they are using, and if then they popped one label and 19 is there, then they segregated to VRFA. After that, if I will do it from what router is that? R6 trace route and dot 1.1.1.1 the source 2.2.2.2. You will see 18 and 19. 18 will be the MPLS label and 19 is your MPLS VPN label. Okay. So on HLSR2 also show MPLS LDP. Just come on. Show MPLS LDP binding. Now, if you will see, if you want to reach to 12.1.1.2 and 4, so you need to put label of 18. Okay, but remote binding is also 18, so he put this label one thing. Then show IP LDP forwarding that LFIP table. If you will see, he's saying, okay, you want to reach to 4, put 18, labeled, and then your R222, right? Who initiated 222? Put this 19 label. This V indicate VRF label. Okay, so these are all routes which you have learned. 15, 5, 14. Okay, it's come under VRF. So it is VRF label actually it is called. But this VRF label you have to understand this RD, RT, and VPN. Okay, this is VRF label. This is also a VRF attribute. This is the only RT is attribute of BGP. But the common thing between these three is Empty Bgp protocol will only going to carry these three things: RD, RT, and VPN label. Without other, that's why Empty Bgp is important. So whenever you do any scenarios, because we're going to do a couple of scenarios, 2-3 more scenarios are there, which I will show you step by step. First, be good with this. Okay, then RD, RT, and VP. Just remember the difference between. That is the main difference, basic difference. Should know. Okay. Okay then. This is your basic practical of MPLS VPN. Just go through. If we have any doubt, we can discuss. But first, do this practical. Then we'll discuss other things. Okay. Tomorrow I will start your DMPP. I'll see you tomorrow.